turtle and good string. So this question is quite simple once you understand the problem. So the problem is we have a string s, or in fact turtle has a string s, and we want to tell him whether the string s is a good string or not. Now what qualifies as a good string? So a string s is good if there exists a sequence of string t1 t2 up to tk such that k is greater than or equals to 2. So that means this sequence of string should be at least 2. That means that we should have at least 2 such strings. Okay, and the concatenation of these strings should represent s. So if s is abc, and we have, let's say, 2 such sequence of strings, so what can they be? They can be a plus bc or ab plus c. Now what's the last criteria for the string s to be good? These sequence of strings are such that the first character of ti is not equal to the last character of tj for any I comma j, and obviously ti not equal to tj. So let's first understand the problem statement. Now let's say we have a string s equals to a b c. What we need is, we need t1 comma t2 comma up to tk sequence of a string such that the concatenation of these strings result in s. So what we need is, we need t1 plus t2 dot 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 tk, and that should equals to s. In other words, since we have a s, we need to partition s into 2 or more than 2 substrings. Okay. Now we have to partition it in such a way that the first character of t1, that is t1 0, the first character of t1 should not equal to the last character of any string. So for t2, for simplicity, let's assume the size of all the strings are n. So yeah, or we can assume the size of t1 is n1, the size of t2 is n2. By size I mean the length of the string, and the size of tk is nk. So for s to be a good string, t1 0 should not equals to t2 of n2 minus 1 should, and this similarly t1 0 should not equals to t3 of n3 minus 1 and up to t up to tk of nk minus 1. So this is a condition for t1. This same condition will hold for t2, t3 and tk. Okay, so what can we do with this condition? Let's see. Let's take the same string abc, and instead of thinking into like k substrings, let's say k is 2, because we need at least 2 strings. Now if we have k equals to 2, so we need to partition this into 2 substrings such that the concatenation becomes abc. Now let's say if we partition this and you have this 2 string, what will be the first character of this string? It c. Let's say this is a, this is b, c. And another possibility is the first string is ab and the last is c. Now whatever you do, the first character of t1 will be the first character of s. This is s, this is t1 and this is t2, and the last character of t2 will be the last character of string s. Now if the first character and last character are not equal, that means our third condition holds. What's our third condition? The first character of ti is not equal to the last character of tj. So if the first character and last character of S are not equal, we can partition this string into two ways. Either if we have a string of length 3, we can partition, and we have k equals to 2, then we can partition this string into two way only. So the first character of S is A and the last character of S is C. So in whatever you partition, T1 will have the first character of A. The first character of T1 would be the first character of S. So first character of T1 would be the first character of S. Okay? And last character of T2 would be the last character of S. Okay, this is the first, let's say S0 and S of n minus 1. Now if these are equal, then that means our string is not good, and if these are not equal, then that means our string is uh, good. Okay, so currently we have seen for k equals to 2, if the first and the last character are equal, then that means our string is not good, and if the first and the last string are not equal, then that means our string is good. But what happens if k is greater than 2? You will see that this holds for even k is greater than 2. How? So let's say we have a string S, which is S1, S2 and Sk, where this is Sn, where Si are characters of ith character of S. Now what we are doing, we are partitioning this string into k substring. So first string will start from S1 and it will go up to some S. Uh, let's say it goes for Sk. Then the second string will start from Sk plus 1 and it will go up to let's say Sl, and then this will go on, and finally we have, let's say, some string, the last string, it will start from, let's say, some Sp and it will end at Sn. So these are our substring. Okay, now we want for every t, so these are t1, t2 up to tk. Now for every ti, we want that the first character should not equal to the last character of tj. So this first character, that is s1, should not equal to the last character of this string, that is sl, and it should not equal to the last character of t3. Similarly, it should not equal to the last character of sn. So even in this case, s1 should not equals to sn for s to be good. Now same holds for these strings, and these strings, and we want to partition them into two or more than two substrings, and we see that this condition holds for even k greater than equals to 2. So that means if the first character, that is s of 0, not equal to the last character of s, then it's a good string, otherwise it is not a good string. Okay, so we just have to check in this question whether the first string, whether the first character of s equals to the last character of s or not. If they are not equal, then we'll print yes. If they are equal, then we'll print no. Here py and pn are just a short form for this: cout yes and cout no.